Hi, my name is Marsha binti Muhammad Najib and I'll do the introduction. Have you ever wondered how pipeline systems actually work in oil and gas industry? Well, basically, it is the implementing of Bernoulli principle, where Bernoulli principle takes into account the work done by power force, also kinetic energy, and also the potential energy, where it is also take into account the head loss, which is force divided by the gravity. The head loss also can be present in the Darcy-Weisbach equation.
Hello guys, I'm Rashwinder Singh and today I'm going to present the fundamental concepts of head loss in a pipeline system. So, definition of head loss. Head loss is simply referring to the friction loss in a pipeline system. So, types of head loss. There are two types of head loss. One is the head loss simply due to the length of the pipe, and another head loss is due to the local losses, which is due to the fittings, bends, and so whatever. So, factors that cause friction loss or head loss. The first factor is the length of pipe. Second factor is the inside diameter of a pipe. Then the third factor is roughness of the wall inside of the pipe. Next, corrosion and scale deposits, which also affect on the friction loss. The more the corrosion, the more the friction loss. Then we come to the straightness of the pipe. As you know, if the pipe is more straight, there will be less friction loss. And next, pipe with fittings. Pipe with more fittings have more friction loss. Then viscosity of the fluid. Viscosity of the fluid also influence on the friction loss. And then the flow rate. Flow rate is another factor which also influences a lot on the friction loss. Okay, now I'm going to talk about the applications of head loss in pipeline systems. So, we need to know the head loss in this house, so we can know how much pressure do we need to send the water to up of the house, up in the tank. So, okay, next. This is a pipeline system in a residential area. We need to know the head loss in order to know how many pumps we need in the pipeline system. That's all. Thank you.
Hi, my name is Union A. Today I would like to discuss about the results and discussion of the oil and gas pipeline system. Okay, we have to apply Bernoulli principle here. So we have to use pump in this oil and gas pipeline system because of high viscous oil. So the pump work should be in the energy input side, and it will result with a friction or total head loss in the output side. The materials used for the pipeline system, steel and PVC. And there are certain fitting and valves used in this system. The most common valve we use are gauge valve and this is globe valve. And these are the fitting values that we have to consider for the calculation for head loss. Okay, the characteristic of the flow, it is usually like denoted by Reynolds number. If it's less than 2000, it's laminar, and if it's greater than 4000, it's turbulent flow. Okay, the Reynolds number we can simply calculate by rho dV over nu. Rho is density of the fluid, and d is internal diameter of the pipe, and v is velocity, and nu is viscosity of the fluid.
Okay, so my name is Zafran bin Hisham. Today I will continue with the result and discussion for part 2. So there are basically two concepts of energy losses, which is major energy losses and minor energy losses. Major energy losses is basically the head loss due to the viscosity of the fluid in the pipeline, the diameter of the internal pipeline, and the velocity of the fluid. While minor energy losses is the head losses due to the fittings installed, the contraction in the pipeline, and the enlargement in the pipeline. So this is the head loss formula, which is the component of the velocity, the length, the multiplier factor, the diameter, and the gravitational is involved. Oil and gas industrial pipeline, we can take Tapis Oil pipeline as our reference. Tapis Oil pipeline covers about 140 miles. So it is about 200 kilometers away in length. So 200 kilometers of pipeline, we need to have good specification and good method in order to transport the oil and gas. So how to reduce the head loss due to the friction is to increase the diameter of the pipeline, is to reduce the fittings installed in the pipeline. So the final method is to use dilution method in reducing the viscosity in the pipeline. So when we use this method, we can reduce the viscosity and then we can minimize the head loss due to the friction. Thank you.